So exercise 1 on the front page are 4 functions that have been translated and stretched and everything. So I'm going to give you 5-8 minutes to go ahead and make as much progress on graphing those 4 things as you can. If you're watching on video, I am going to pause this so as not to take up more time. Okay, so I have done the basic graphs for each of those. So I know some people, some of you in here, you still need to do the basic graphs, and that's great, nothing wrong with it. Others of you, you may be able to skip that step. That is fantastic as well. Different people learn at different paces. Also depends on how much practice you've been doing. So just so that we're all starting from the same place, I've done the 4 basic graphs in pencil. So for graph 1, f of x is equal to x squared minus 4. What is being done? There's one thing being done to this parabola, and what is that? Yes, this one's going down 4. That minus 4, that is outside the x squared, means take that whole graph and move it down 4. So I will do that. So I'm going to move all these points down 4. And your graph should look something like this. If you got something different than me, then let's talk. Oh, that's beautiful. That might be the best I could possibly ever do Great job, Perkster. Okay, so any questions about the x squared that's been moved down 4? Okay, we're going to move now sideways. Here's my absolute value graph. I've drawn the basic V right there. Now, in this case, 2 things have been done to this graph. What 2 things are being done to this absolute value graph? All right, it's going right 3. That -3 tells me to go in the positive x direction 3 units. That's great. What else is being done? Yes, indeed, the +2 means go up 2. So those 2 things. So I'm going to take my graph. I'm going to move the whole thing. I'm going to go right 3, 1, 2, 3, up 2. That's my vertex. I haven't stretched or shrunk it at all. So I know that my slope going right is 1. My slope going left is -1. And here is my V. This, and you can wave goodbye to the green pen. This is its last graph. Congratulations. Okay. Questions about that one? Comments, concerns, conundrums? Anything at all bothering you? Okay, we're going to go down to the next one. I've got a nice cube root graph. Again, I've drawn the basic graph right there, firstly. So 3 things are happening to this graph. And if you remember my advice to you, we're going to do this one in phases. Okay, we're going to do one thing first, and then we'll take care of the rest. So tell me any one of the 3 things that are happening to this graph right here. Okay, we're going to multiply the y's by -3. That's excellent. We will do that. Multiply the y's by -3. What else is happening to this graph? Okay, it's going left 1. That +1 is moving the graph left 1. And then what other thing is happening to this one? Perfect. You're not seeing where we're getting those, that would be a fantastic question or a good reason to drop by my office or an excellent situation in which to click on the TLCC online tutoring on Canvas and make sure you get help, because this, what we're doing in class, is just what your test is going to look like. Okay, so I gave you the advice when we talked about this to always do your multiplying first, order of operations. I'm not going to try to do all 3 things at once. I would not advise doing the left one up 2 first. You can, but it's a much more difficult process. So here we go. I'm going to take all of my y values by -3, just going from left to right. This y value is -2. So -2 times -3 is 6. So I put a dot up here at 6. This y value is -1. -1 times -3 is 3. Put a dot here at 3. 0 stays 0. This y value is 1. 1 times -3 is -3. So I put a dot here at -3. And finally, this y value is 2. 2 times -3 is -6. I put a dot here. And just so that I don't make too big of a mess out of this graph, I'm just going to make a nice dotted little cube root that's been multiplied by -3. So that for your notes, you see what I've done. I'm going to just put -3 times the cube root of x right there, so you know that what that represents. All right, once we've got that, we are ready to head to the finish line of this problem. I'm going to take that dotted graph. I'm going to move the whole thing left 1 and up 3. So left 1, up 3, boom. Left 1, up 3. Left 1, up 3. Left 1 up 3, and then finally left 1 up 3. And so what we have here is this. I hit all the dots. Really proud of myself. That is a beautiful looking graph. Whatever I had for breakfast, I had to do that again. I'm drawing great today. Yes, did I do something wrong? Went up 3, didn't I? Man. I was so happy and confident about my graph, wasn't I? Oh, you all deserve better than that. Oh, and I was hoping to use those notes as my... That's okay. I can survive this, the embarrassment. We got this. Not going to post that one to Instagram, that's for sure. Okay, let's try again. So I'm just going to real quick, I'm going to reproduce that dotted graph. So I'm at -8 and then at +6. And then I'm at -1 and 3 and 0, 0 and 1, -3. And then 8 and negative 6. And so this is where we were. We're going to pretend like that never happened. Okay, and now I'm going left 1 and up 2. Okay, I can't believe you all made that mistake, but I'll fix it for you. Left 1 and up 2, left 1 and up 2, left 1 up 2. Oh, this looks way better than the other one. Let's see if I can hit all these dots this time. I was so super confident. Just not as good, but that's okay. There we go. Sorry, everybody. Sorry, anybody watching the video. Too bad, though. Okay. Are we all on the same page now? All right. I just want to make sure you're all awake. Appreciate you being awake. That's good. Okay, so back to here. I've got my basic square root graph. What two things that I may or may not pay attention to what you say when I draw my graph are happening here? Okay, up 2, we got that. That plus 2 is up 2. What other thing are we doing? I'm not gonna, did you say distributing? Flipping? Okay, yes, we're gonna flip the graph. And the reason we're gonna flip the graph or reflect the graph is this negative out front means to multiply the y's by -1. But we know that that is a reflection about the x-axis, or flipping it about the x-axis. However you want to communicate that is beautiful. I love it. So I'm going to do that first. I'm going to multiply the y's by -1. I'm going to flip it. So this, instead of +1, is -1. Instead of +2 is -2. Instead of +3 is -3. I'm just going to make this dotted. This is my transition graph. This is -√x right there. All right, and if I can do this now without embarrassing myself, I'm going to move that up 2, if I'm counting right. So up 2. So up 2 here, up 2 here, up 2 here, and then up 2 right here. And here's my graph. Not too bad. Good recovery. All right. Any questions, comments, concerns? That's graphing. We're probably not going to review it again before the test. So if you are struggling, get help. Please, I beg you, because the first 4 problems on the test are going to look just like what you did. So if you did better than me, you are going to do great on the test. Okay, so there you go. All right, flipping the page. So today what we're talking about are absolute value. We're talking about absolute value functions. And so we're going to be incorporating the idea of the absolute value into what we're doing today. So my example 1 right here, I'm going to take this absolute value graph that I've started with, that's pointing downward. It's been moved up 6. And what I want to do, this is the first skill we're going to practice today, is I want to take this graph and now I want to graph the absolute value of f of x. Okay. I want to take the graph I have and I want to know if I take the absolute value of this whole function, what does it do? Okay. Well, remind me, because we talked about this before, when I take the absolute value of something, what is always the result? It's always positive. So basically what you have to remember is when you put some absolute value bars around your function and you're doing this to your graph, the result is always positive. So what that means is when you take the absolute value of a negative number, it becomes positive. When you take the absolute value of a positive number, it stays positive. Okay, so once again, I've reminded you of this thing 2 other times, but I just want to make sure this notation, this f of x notation, that is just my fancy college algebra notation for saying what? What value? The y value. So we're going to take the absolute value of our y values. So I'm just going to go piece by piece here. And so I notice over on the left part, these y values here that I'm tracing over with my pen, are they positive y values or are they negative y values? They're negative. So when I take the absolute value, all of these values are going to become positive. So this value that's -3 is going to become +3. This one that's -2 is +2. -1 becomes +1, all the way to 0. So I'm just going to connect the dots there. There we go. So the orange one, I probably should have picked a better color. I apologize. The orange one is the new graph. It's the absolute value graph. Now these points that are in the middle, okay, these y values that I'm now tracing over, the triangle part of the graph, are these values negative or are they positive? They're already positive. So when I take the absolute value of these y values, they are going to stay the same. Would you agree with that? Okay, so that means because these are positive, I'm just going to trace over them. So again, sorry, I should have picked a more distinct color from the red that is on the original graph. But I'm just tracing over. That is my absolute value. You kind of see what's going on here? We doing okay? Any y values that are negative, when you take the absolute value, they're becoming positive. Any positive ones stay positive. And so now on the other side, where the original graph now dips below the x-axis, these are now negative. They're below sea level. Okay, so now I will make these positive. So +1, +2, +3. So the new graph looks like it's bouncing along the x-axis. If you have a question, be sure to ask it. I would appreciate and love any questions that you have. If not, what I would like you to do next is example 2. I've given you another graph that has a starting and a stopping point, and I'd like you to do the absolute value of g of x. All right, well, once again, I'm going to do this in pieces. So this initial part of the graph, this is already positive. Okay, so when I take the absolute value, this part's going to stay positive. So I'm just going to trace over it. There you go. So it stays positive. The red one is my new graph. Now, all of these values, this triangle here that is underneath the axis, okay, those are going to become positive values. So I've got this -2, -4. So that's going to become -2, +4. And I notice my ends of my triangle, this is where it goes through the x-axis here. This is where it goes through the x-axis over here. So my graph's going to just look like this. It should just be the mirror image, okay, like you're standing there looking at a lake, and you can see the image above and the image below. And then lastly, the last bit of triangle of this graph is already positive. So again, I'm just going to trace over it because when I take the absolute value, it's going to stay positive. So the red graph right here is my new graph. And that's done. That's the absolute value. Any questions about that? That one students sometimes find to be more difficult than some of the others, just because it goes through the axis so many times. So if you have a question, please feel free. If they're great questions, I'm sure. Do the same thing for example 3 then. Oh, I'm going to use a better color than that. Let's use this. So for example 3, let's do the absolute value of h of x. So the left side of this graph, have negative y values. So when I take the absolute value, all of these values that I'm going over with my pen right now, these are going to become positive. So it looks like this is -2, so I'm going to raise it up to +2. It looks like this is -4, so I'm going to raise it up to +4. And so it's just going to look something like this on the left side. And then on the right side, all of these values are already positive. So when I take the absolute value of these, they're not going to change. So this graph now looks like how I used to draw birds in elementary school. There you go. Questions about that? We're just going to do, we're going to do one more graph here, and then we're going to go back to one of the ones we drew previously, do the absolute value of it, and then that's enough of graphing absolute value. We're going to talk about equations involving absolute value. So here's a fun graph. If you take pre-calculus, you'll come to recognize this as what's called a sine wave. You don't need to know that right now, but please go ahead and graph the absolute value of this. So I'm going to get started while you're working. Keep working. The positive parts are going to stay positive. The negative parts are going to now bump up. So it's just going to look like that this graph is bouncing along the x-axis, something like this. And then this is going to go up to 4. So, and it's going to go up to 4 again, somewhere right there. And there's my graph. Okay, so now the blue one, that's the absolute value of the original graph. I've got one final example for you. So if you have a question, go ahead and be sure to ask it on the front page where we graphed x² minus 4. And you told me that that graph just went ahead and dropped down 4. What I would like you to do now is take that graph and graph the absolute value of x² minus 4. So the absolute value of the graph that we drew. All right, so on this one, the left and the right side here, I'm just going to trace over. These are already positive values. They're going to stay positive. And then these negative values here, I'm going to now bump up. And so here's what my graph looks like again. It's just bouncing right off the x-axis, and it looks like that. Just the reflection. All right, so that's enough graphing unless I hear a question. Anybody got any concerns about graphing? I'm going to ask you to do that a time or two on the test that you have coming up. Okay, so I think the test that you have coming up is a week from today, if I'm not mistaken, because we have one more section after this section to be done with this unit. Okay, so I'm heading to the last page, or excuse me, the second to last page, page 3 of the packet that I gave you. And so now what we're going to do, since we're on this topic of absolute values, we are going to solve equations that involve absolute values in them. Okay, so the first example that you and I are going to do are going to be nice and relaxing, just to kind of get us centered and understand how this works. So this is as simple an absolute value equation as I can possibly make. And we are going to solve this just from your knowledge of absolute value. What number can I plug in here for x? And the absolute value is going to be 7. Okay. What other number? Perfect. There are 2 solutions to this. Please notice x is 7 and x is -7. Both of those, when I pop them right in there for the x, take the absolute value, I get 7. So I have a solution set with 2 things right here. Notice I'm using squigglies. Okay, notation's important. If you use parentheses here, you're telling me an interval, and that's wrong. So we're using braces as my set because there's only 2 values in there. There's not an infinite number of values. If you're good with that, then move over to exercise 5 right next door and go ahead and solve that for me. I don't think this is going to take you too long. What values can x take in order to produce 12? -12 and +12. There are 2 solutions to that. So far, so good. Does anyone not understand why there's 2 solutions to those absolute value equations? That's super important to your immediate future, the very next problem. Okay, well then my next example right below the one I just did now says, okay, inside the absolute value, instead of an x, I have some other expression, in this case, 2x minus 5. Now you just told me a moment ago that inside the absolute value, in order to get a result of 7, I could plug in either a -7 or a +7 inside the bars. So here's how you're going to solve an absolute value equation. Okay, from now till the end of the semester, we're going to say this. I'm going to scoop out this stuff that's inside the absolute value, that 2x minus 5. And I'm going to say that that 2x minus 5 can take on 2 values. That 2x minus 5 can either be -7. Okay, if it equals -7. Uh-oh, my pen's disobeying me here. So that can either equal -7, or my 2x minus 5 can equal +7. So all I'm doing here is I'm saying this thing that I circled inside the absolute values, whatever it is, it does not matter at all. If I replace what I've circled with a -7, or if I replace what I've circled with a +7, then the absolute value will be 7. So notice, did I do anything to the expression on the left? Did I do anything to the thing that was inside the absolute value bars? Did I change any signs on it? That's always the temptation students have, is to say, oh, I'm taking absolute value. Let's make this 2x plus 5. Okay, that's wrong. Please do not do that. And now I'm going to solve these 2 cute little linear equations. So I'm going to add 5 to both sides of this, and I get 2x is equal to -2. I'm going to divide both sides by 2, and I get x is -1. There's my first solution. And you can always check. Grab your calculator. 2 times -1 is -2. -2 minus 5 is -7. Absolute value of -7 is 7. There we go. It checks out. The other one, I'm going to add 5 to both sides of this, and I get 2x is equal to 12. Divide both sides of that by 2, and I get x is 6. So my solution set is -1 and 6. Does anyone have a question, comment, or concern about how I got 2 solutions and what they are? Okay, well, then we're going to move on. I'm going to just Try to keep this as interesting as possible until there's a question. Do exercise 6, please. So it's my hope that you have written down and solved 2 equations. What's one of those equations? Perfect, that's good one. 3x minus 9 equals 12. So I can scoop out this thing that's inside the absolute value, and the thing that I just circled can take on the value of 12. Great, what's the other equation? 3x minus 9 equals negative 12. Excellent. Okay, again, notice the thing that I've circled in the absolute value, I've not changed at all. It's 3x minus 9. And that thing that I've circled can either be negative 12 because the absolute value of that is 12, or it's positive 12 because the absolute value of that is 12. So now it's solving these, add 9 to both sides, and I get 3x is equal to 21. Divide by 3. The first solution is 7. Over here, add 9, and I get 3x is equal to, I did it again, didn't I? Good job, Perkster. But this time, no one found it. So 3x minus 9 is negative 12. I added 9 and then somehow got 21 there. I don't know how that worked. So I'm going to add 9. This should have been negative 3. Now I'll divide both sides by 3, and I get negative 1. I'm 2 for 2 this morning. I'm doing great. All right, this time I add 9, and I get 21, and then divide by 3, and I get 7. There we go. I knew 7 was a solution somewhere. So my solutions to this are negative 1 and 7, if I can do arithmetic. All right, so if anyone's got a question, comment, or concern other than my sanity, that's great. Next, do exercise 7, please. Once again, we got 2 equations we are going to solve. What's one of those equations? 6 minus 2x equals negative 11. Fantastic. And the other one is perfection. Okay, so I'm going to see if I can do this without making an arithmetic mistake. So I'm going to subtract 6 from both sides of this, and negative 2x is equal to negative 17. Divide both sides by negative 2, and a negative divided by a negative will make a positive, and I'm going to write that as 17 over 2, or maybe you wrote 8.5. Either way, that is fine. On the other one, I'm going to subtract 6 from both sides, and I get negative 2x is equal to 5. Divide both sides by -2, and a positive divided by a negative is a negative 5/2, or maybe you wrote 2.5. Okay, in this case, decimals are fine because they're terminating. And so I have -5/2 and 17/2. That's my solution set. Okay, I've got one more equation for us to do, just because I want you to see everything you're potentially going to see on your homework. So here's the next absolute value equation. And before you get started, there is something that you need to do before you can write down the two separate equations. Anybody got a proposal for me on what I have to do first? Yes. Yeah, get that 5 on the other side. You have to have the absolute value alone before you can break this up into two separate equations. Okay, it won't work the other way. I promise. I've seen students try, they get it wrong. So first thing to do is subtract the 5 from both sides. And you're going to end up with absolute value of 3x plus 2 is equal to 10. And now I'm going to give you 90 seconds to finish that up. Okay, it's just exactly like the other problems. So the two equations I'm hoping you are looking at is you have 3x plus 2 equals -10, and then you have 3x plus 2 is equal to +10. So those are the two things. First one, we'll subtract 2 and get 3x is equal to -12. Divide by 3, x is -4. Over here, I'll subtract 2 and get 3x equals 8. Terrible looking 8. Then divide both sides by 3 and get x is 8/3. I'm going to leave that as a fraction because it's a repeating decimal and I don't want approximations. I'm giving exact answers. So -4 and 8/3 are the two exact answers. All right, do we feel pretty solid about solving an equation involving absolute value? We doing okay? All right. So the next thing, and pretty much the last thing we've got going on today with our absolute value section is this. This is the first time we're going to be solving an inequality that's not linear, like we reviewed in section 1.5 way back in the previous unit. I'm going to show you a process to solve an inequality that we're going to use many times in this class. Okay, we're solving absolute value inequalities here. We're gonna come back in the next unit. We're gonna solve quadratic inequalities. Then the unit after that, we're gonna solve rational inequalities. We're gonna solve exponential inequalities. We're gonna do all sorts of inequalities, and every time we're gonna use this same process. Okay, so I want you to kind of internalize this now. I know it gets repetitive and it's the same thing every time, but it's to your benefit, I promise you. So when you are given an inequality here, whether it's absolute value or any of the ones we do in the future, the first thing you're going to do, step 1, is you're going to solve the equation. We've already done that. If you look up at example 6 is the equation that's related to this. It's absolute value of 2x minus 5 equals 7. Okay, that's what I mean by solve the equation. Just replace the inequality with an equal sign. Okay, so we've already done this, so I'm just going to make a little note on this one from example 6. That solution is -1 and 6. Those are the 2 points of equality. So I've done absolutely no new work. When you do your examples of this, your first one is going to be related to something we already have done. Your second one is going to be a brand new one. The second thing that you're going to do, is you're going to draw a number line. And what this number line represents is it represents the domain. And we know from seeing the graph of the absolute value that the domain of the absolute value is negative infinity to infinity. So I'm going to go from negative infinity to infinity. I'm going to label the ends of this. Okay, this is going to be a very helpful practice for you when we do things that the domain is not negative infinity to infinity. Okay, so I'm doing this intentionally. And what we're going to do is we're going to label on the number line the points of equality. So I'm going to put -1 right here, and I'm going to put 6 right here. So what we've done on our number line is we've created 3 intervals. We've created the interval from negative infinity to -1. We've created the interval from -1 to 6, and we've created the interval from 6 to infinity. And if my graph is equal to, if it's equal to 7 at both of these points, okay, if it's equal to 7 at both these points, then it stands to reason that the graph has to be either above or below 7 in each of these intervals, because there's no other places where it's equal. So now what you do, this is step 3. Step 3 is you're just going to test the intervals. And we are going to determine which intervals give us a result that is below 7. So here goes. What do I mean by test the intervals? I'm just going to pick a number in each of the intervals to represent. So give me a number that falls between negative infinity and -1. Sure, that's a great one, -2. And I'm going to circle it because I don't want you to mistakenly think that's an endpoint. And here's the question we're going to ask. When I plug -2 into my original absolute value, do I get a number above 7 or do I get a number below 7? Well, let's see. When I put -2 in, what's 2 times -2? -4. What's -4 minus 5? -9. What's the absolute value of -9? 9. Is 9 bigger than 7 or is 9 less than 7? Okay, I'm going to put a greater than here for bigger. Is everyone tracking with me? I'm just trying to set up this process. It's going to be handy here for you to get the right intervals on this. And then this process is going to be very handy and streamline our work when we have even more complicated inequalities. Give me a number that falls within the interval from -1 to 6. Yes, my favorite number between -1 and 6. Yes. We're going to plug in 0 into our original absolute value. So I'll do that. Again, just to make sure you're awake, 2 times 0 is? Minus 5 is -5. And what's the absolute value of 5? -5. 5. Is 5 bigger than 7 or less than 7? Okay, so I'm going to put a less than right there. And then finally, give me a number in this last interval from 6 to infinity. Sure, 7 or 19 or 142, whatever you feel like. And so when I put 7 in, 7 times 2 is 14. 14 minus 5 is 9. Absolute value of 9 is 9, which is bigger than 7. And so now we're going to answer the question. I want to know what x values on my number line is the absolute value less than 7. Which interval or intervals is the answer to this? -1 to 6, that's where I have the less than sign. The other 2 intervals have greater than. So if the original question was where is it greater than, you'd tell me those intervals. And now what am I going to put at the -1 and the 6 end? Brackets or parentheses? Why am I putting parentheses? You're exactly right. Perfect. There's no equals on my original. I'm not interested in the points of equality, so I'm going to put some parentheses around that. Wonderful. Okay, so what I would like you to do then is exercise 9. Follow those same 3 steps. Exercise 9 is based on exercise 6, so you already have solved the equation. Bless you. Right, so on this one, we've already solved the equation. So step one, solve the equation. That from exercise 6 is -1 and 7. So step 2 is I'm going to draw a number line that represents the domain. And so for my absolute value, that's -infinity to +infinity. And I'm going to put those points of equality on there, -1 and 7. And now I'm going to test each of those 3 intervals. So it does not matter what value you picked in each of these intervals. We should all come to the same conclusion. So if you get a different conclusion from me, let's talk about that. So if I put in, let's say -5 from negative infinity to -1, 3 times -5 is -15. -15 minus 9 is -24. The absolute value of that is +24, which is bigger than 12. If I put in 0, 3 times 0 is 0. 0 minus 9 is -9. The absolute value of that is 9, which is less than 12. And then on this last one, I'll plug in 10. 3 times 10 is 30. Minus 9 is 21. The absolute value of that is bigger than 12. So now we're going to answer the question, where are my bigger than 12? What interval or intervals answer this question? -infinity to -1 with a parenthesis because there's no equality. Union. Perfection, 7 to +infinity. So there are 2 intervals where that produce values bigger than 12. Any questions? All right, on the last problem on this page, exercise 10, you have to do the whole thing. So you got to find the answers to the equation, and then you've got to solve the inequality, please. So I'm going to get started. If you're working, keep working. It's not intended to rush you. So first thing I need to do here is I need to solve the equation. So first step is I need to solve absolute value of 4 minus 2x equals 10. That involves solving two related equations. So 4 minus 2x equals negative 10. 4 minus 2x equals positive 10. Subtract 4 from this one. Negative 2x is negative 14. Divide by the negative 2, I get 7. Here, I don't know why I wrote an x there, so the follies continue today. I'm going to subtract a 4 and get negative 2x is equal to 6. Divide by negative 2, and I get negative 3. So I believe if I've done my work correctly, which you should definitely be checking as things go today, I get negative 3 and 7. Are we so far so good? That's the equation. Now the inequality, step 2, is I'm going to draw my number line that represents the domain of the absolute value. So my domain is negative infinity to positive infinity. I'm going to put those 2 points of equality on here. And now we're going to see what happens when I test the different intervals. So when I test over here, I'll put in negative 4. Negative 2 times negative 4 is positive 8. Plus 4 is 12. That is bigger. When I put in 0, 2 times 0 is 0. 4 minus 0 is 4. That's smaller. And then finally, when I put in, let's say something like 9, negative 2 times 9 is negative 18. 4 minus 18 is negative 14. The absolute value of that is bigger. So what answers my question? Where is this bigger than or equal to 10? Well, from negative infinity to negative 3. This time, though, at negative 3, since I am interested in the points of equality, because of that equals, I'm going to put a bracket. And then same thing from 7 to infinity. I'm going to use a bracket there as well because I'm interested in the point of equality. We good? Any question at all? Because what we've just done on that page is exactly what I'm going to ask on the test that we have a week from today. Okay, it's not going to look any different. So please do that. Solve it. Do well. I want lots of A's on this next test. Okay. Just a couple more things to mention, and then we'll be done talking about absolute value. There are some special cases that I don't want you to fall victim when I put one of these on the test or you encounter on the homework. So the first one, exercise 11. The absolute value of x minus 1 equals negative 1. What's wrong with that statement? Yeah, what does the absolute value? The absolute value always gives me a what? What that means is that there is no x value that I would put in that would give me a negative. Okay, so I will never get a negative 1 right here. So for that reason, what would you propose is the solution set going to be? No solution. So when we have no solution, we write empty set. Okay, there is no x value that when I plug it in is going to give me an absolute value that's negative. So there's no solution to that. Okay. Well, then I'm going to give you a moment to think about. Okay, so look at exercise 12. Think it through. It's another one of the special situations. I'm going to give you 1 minute to think about it, and then we'll talk. Okay, so this time, again, I've got an absolute value that's always positive. This time, my relationship I've given you, though, is that it's greater than negative 10. So here's the question that I was hoping you'd think about. And if you didn't get this, it's okay. That's why we're doing the problems in class. When is a positive number bigger than -10? Always, right? Positives are always bigger than a negative, no matter what the size. Okay, so this is always true. No matter what value of x you plug in on the left, you're always going to get a positive result. And so a positive number is always bigger than -10. So that means my solution set here is -infinity to infinity. Even if you didn't get it at the first go around, I understand why you might not have. Do you see why that's true? Does anyone not see why that's true? All right, well then I'm going to give you a minute. Think through exercise 13 and determine what you want to write as your answer for it. Okay, this one, again, I've got an absolute value. This is always positive. This time, the relationship I give you is I've got this number that's always positive, less than a -5. So much like our first example, 11 on this page, can a positive number ever be less than a negative number? No. Positive numbers are always bigger than negative numbers. So for this one, it's never true. It's never going to happen. So this is another example of an empty set. Okay, there's no solution to this problem because a positive number is never going to be less than a negative number. All right, any questions about those? Keep your eyes peeled. There'll be a couple of those on your homework. I will throw one of those on the test just to be spicy. Okay, so the last problem we're each going to have is one more equation. And my hope here is that you see that these equations are no more complicated than we've already done. So here's what we're going to do for my example 8. We're going to pretend, okay? We're going to pretend that this is page 1. So this is the land of make-believe. And instead of the absolute value of x plus 6 equals the absolute value of 2x minus 3, you're just real quick going to remind me, what did we do when it was the absolute value of 6 is equal to something like 10? Okay, how did we solve that equation? Yes, we've got the x plus 6, and then we set it equal to -10, and we took the x plus 6 and set it equal to +10, right? Does everyone remember that? I know it was like 45 minutes ago, and you're probably bored to death. Half of you probably are asleep. I understand. I get it. Okay, so I'm just reminding you what we did when we have a number over here. My process is no different when I've got an expression over here. So here's what we're going to do on this problem. We're going to take my x plus 6. We're going to scoop it out just like we did before. And what I'm going to do is I'm going to set it equal to my plain old 2x minus 3 when I get rid of the bars. Notice I'm not, sometimes students want to take the absolute value of this 3 and make that a plus 3. I've not done that. You would never do that. And then the other equation is going to be the x plus 6 is equal to negative 2x minus 3. So I'm putting a negative out in front of the parentheses. So notice I've done the exact same thing we did when it was just a number. When it was a number over here, we set the x plus 6 equal to the positive and the negative of the 10. Same thing here. I took the x plus 6 and I set it equal to the positive and the negative of the 2x minus 3. Same exact process. Only caution I'll give you is don't forget to distribute here on this right-hand one when you've got the negative. So let me take care of business here. So what I'm going to do here is I'm going to subtract the x from both sides of this equation and get 6 is equal to x minus 3. I'm going to add the 3 over, and I get the solution, 9. On the other one, I'm going to distribute that negative, and I get negative 2x plus 3. I'm going to add the 2x to both sides, and I get 3x plus 6 is equal to 3. Subtract 6. 3x is negative 3. Divide by 3. X is negative 1, and my two solutions are negative 1 and 9. So I just kind of flew through the algebra, which I'm hoping is so second nature to you at this point in your math lives. So last problem for the day. This is how we're going to finish. I'm going to leave that what I just did up there for you to model. Exercise 14. Same sort of thing. Okay, as we attempt to wrap things up here, somebody give me one of the equations that we're going to solve. Okay, x minus 4 equals 7x plus 12. So I just dropped the absolute value bars on both sides. Great. And what's the other equation that I'm going to solve? You distributed already, which is fantastic. I'm just going to put the negative out front this first time. But yeah, if you want to distribute right away, that's totally amazing and great. Okay, so now we'll finish this up. I'm going to distribute just like was already done for me. So I have negative 7x minus 12. I'm going to add the 7x over and get 8x. I'm going to add the 4 over and get negative 8. So when I divide by 8, I get x is negative 1. Lots of negative 1s on this sheet. I need to be more creative. On this other one, I'm going to subtract the 7x, and I get negative 6x. I'm going to add the 4, and I get 16. And when I divide both sides by negative 6, I get negative 16 over 6, which is negative 8 over 3. So my two solutions to this are negative 8 over 3 and negative 1. All right, everybody survived another day of college algebra. I hope you have an amazing day. I'll see you.